All right, let's go over our homework and see how you did on your introduction to Bivariate data. So here I put this into my calculator. I did stat calc ln reg, got a slope of negative 5.14, y-intercept 98.07, r. So you got to be careful on this. I think r squared shows up first um, in the assignment or in the calculator. Okay, so just make sure you get that correct. Now, r squared is next, or 0.9031. I think I go to 4 places on this so that when I change it into a percent, I'll still have 2 significant figures because I'll know I'll change this into percent. So the explanatory variables absences response was grade. Here's your equation with the slope and the y-intercept. Make sure you have this prediction hat or it's wrong. Okay, so now interpret the slope. For every one increase in the x, the predicted y, it does this. Interpret the slope. For every additional absence, the predicted grade goes down 5.14 points. And it can be an approximate, or it can be a number that doesn't make sense because you use this word predicted. It's going down. You could also say for every additional absence, the grade goes down about 5.14 points. Okay, so remember you can use predicted or about, but not both. All right, y-intercept. Interpret the y-intercept. It happens when the x is 0. The predicted y is this, and it often does not make sense. So this one actually isn't too bad. This says when a student has no absences, he or she is predicted to make a 98.07. So you could say when a student has no absence, he or she will make about a 98 in the class. Here is interpret the value of the correlation coefficient. They're going to say describe the relationship. Okay, describe the relationship. I should start putting that in there. Describe the relationship means discuss this correlation coefficient. And that's when you say there is a strong, there is a weak, positive or negative linear correlation between x and y. Linear between x and y. Okay, so here negative 0.95, we have a strong negative. It is linear relationship between absences and grade in the class. If it's curved, we would say nonlinear. So at this point, we just classify it as linear nonlinear. Interpret the value of the coefficient of determination. Coefficient of determination. So it's the percent of variation that is found in the y. So about 90.31% of the variation in grades in the statistics class. It can be explained by the changes in the x, the fluctuation. It can be explained by the fluctuation in the number of absences the students have. Or it can be explained by the model itself, and that's the linear relationship between absences and grades. So you could also say about 90.3%. 31% of the fluctuation in the class grade, the grades in the class, can be explained by the linear relationship between absences and grade. All right, here was another one. You put this data in. It was about advertising dollars and the number of items sold. So here we have those values. So explanatory advertising dollars spent, response number of items sold. So here was our equation. Predicted number of items sold, 0.53 advertising dollars minus 5.32. For every additional dollar you put into the advertising, the predicted number of items sold increases by 0.53. Interpret the slope. Okay? Interpret the y-intercept. When there are no advertising dollars spent, the predicted number of items sold is negative 5.32, and it often does not, in this case, it does not make sense. Here is our remember, they'll say describe the relationship. Describe the relationship means do this. There is a positive linear relationship between advertising dollars spent and number of items sold. R squared, About 95.7% of the variation in the number of items sold can be explained by the varying amounts of advertising dollars spent. All right, those two things there. This was just a really interesting, thought-provoking topic. Sad, but hopefully it didn't offend anybody or give you kind of some trauma taking a look at these different possible explanatory reasons for the mass shootings. See, these are some hard things that we need to look at. How much can we contribute to the rifle production, the mental health, or the violent video game sales? All right, so here we go. So this asked, which of the three seems to be the strongest predictor of the frequency of the annual mass shootings? Well, video game sales appears to be the strongest predictor of the frequency of annual mass shootings. I decided this based on the fact that it has the highest coefficient of determination. It had the highest. So it had almost 70% of the variation in the number of mass shootings can be attributed to the variation in the video game sales. All right, but here's this. Would banning violent video games prevent more mass shootings than banning assault weapons or improving mental health services? Why or why not? And we do not know that, not necessarily. There are several reasons why banning the violent video games will not necessarily prevent more mass shootings than the other two explanatory variables. Like, for example, there could be other traits common to those people who like violent video games. So just violent tendencies altogether, not being exacerbated by the video games. It could be that people who like the violent video games also have those higher rate of those mental illnesses. So those two explanatory variables could be connected. I don't know. So we can't tell if the increase in the coefficient determination is just isolated to violent video games increase or if it's a result of something else in conjunction with the violent video games. So therefore, the main thing is just because there is a correlation or a high correlation, you cannot say, oh, it says correlation does not imply correlation. Okay, that's not correct. Correlation does not imply causation. So causation is what should be right there. Okay, so there is what we were supposed to get on that. All right, is that all that we had there? Yes, it is. And then we did our day 2 notes next. All right, hope you did well on that.